Hey guys, so today we are going to do solving equations, but we are going to solve special case equations. And you'll see why we call it that here in just a little bit. So what we're going to take a look at is how to solve. So just like we've been practicing with our multi-step equations the past 3 days, we are going to look to see, can I distribute? Can I combine like terms? And can I undo my operations to each side of my equal sign? So in number 1, to get started, I want you guys to notice that you don't have any parentheses. So if I don't have any parentheses, then I will not be distributing. So no distributing on number 1. Okay. But I do see that can I combine like terms? Well, I don't see anything on each side that I can combine since they look alike. So no combining like terms. So we are resorting to undoing our operations on each side of our equal sign. So let's undo these operations. How you do so is we look at what we have. So if we look at the r's, to move one of the r's to the other, I notice that 5r and 2r are involved. 2r is smaller, so I'm going to take this positive 2r and I'm going to undo it by subtract. Which is going to leave us with 3r's minus 3 equals negative 3. Okay, we want to get 3r by itself. So if we want to get 3r by itself, I need to undo my operation of subtract by 3. So to undo subtract, we add to both sides of our equal sign here. Keep us organized. Uh-oh, SpaghettiOs. We kind of have an issue here. They both cancel out. But remember that if you cancel out, it means that you're technically left with 0 over there on the right side. Don't overthink that. And to solve for r completely, we need to not multiply by this 3 in front of him. We need to undo the multiply. So we're going to use divide. So the question is what is 0 divided by 3? Well, 0 divided by 3 is 0. This is one of the special cases that sometimes may happen where your equation literally undoes itself on both sides, leaving us with a 0 as our solution. So 0 as a solution. That can happen because 0 is a number on our number line. So don't overthink that. All right, let's try number 2. Feel free, you can pause the video and write as we go as well. All right, so number 2, it's screaming at me. I see parentheses. So as soon as I see parentheses, you know you must distribute to make this easier. So let's distribute 2 times x is 2x, and 2 times positive 2 is positive 4. Now we're going to bring everybody else down. So 2x minus 1 equals. And we're going to keep going here. Give me 1 second. Okay, so we distributed. Now we're going to look to see, can we combine any like terms? And on the left and right side of my equal, I don't see anything that I can combine on the same side. So that means, again, guys, we will not be using any combining like terms. But we can undo our operations from both sides. So we notice we have a 2x on both sides. So to undo a positive 2x, we subtract 2x. Now notice when we subtract 2x, they undo each other on both sides of my equal sign. Notice there is no x left. And we come down to this statement that -1 equals 4. So I want you to think, guys, mathematical wise. Does the number -1 equal the value of something that is 4? And the answer is definitely not, right? Those are not equal to one another. So we're going to make a big stink about this. These guys are not equal. So not equal. So we actually have a name for this. So we call this no solution. So in order to have a no solution, you have to have two things happen. Okay? For no solution, your variables are gone, and what you're left with is not equal. So not equal at end. That'll be the easiest way to describe that to you. All right. Now we have one third possibility as a special case, and we want to talk about him. So let's take a look down here at 3. Do we have any parentheses? Nope. So no distribute. Do I have any like terms that I can combine on the same side? And I hope you'd say yes, because we have a positive 1b, and we're taking away 6 b's on the right. So 1 minus 6 is going to give us -5 b's, along with a 1. All right, guys, and normally in our equation solving here, we will be now moving into undoing our operations. So to undo our operations, instead of subtracting by 5b from both sides, we should add 5b on both sides. Notice that both 5b's are eliminated, or they go to 0, leaving us with 1 equals 1. Well, that, my dears, is true. 1 does equal itself. So this is, in fact, equal. Yay! So if it is equal, then what we say is that any number we plug in for b will work. So we have 2 ways to go about that. We can call this all real solutions, or we can call this infinite solutions. So as many numbers as you can think of, we are allowed to use in this equation, and it will always remain equal to each other on both sides of the equal sign. So because of that, that's why we call it infinite solutions or all real solutions. So again, to have this case, the variables need to go away or they are gone. And 2, they must be equal at the end. Equal at the end. Now, there are a few of you smart cookies in this class, and I want to talk to you quick about the fact that right here in our second step, we had 1 minus 5b equals 1 minus 5b. You were already equal in the second step. The left side is literally equaling the right side. They look exactly the same. So another way you could do that is identifying who looks exactly the same. So you could have known that this was all real solutions or infinite solutions as your answer back in step 1. That you were literally equal from left side to right side. You were exactly the same. All right, guys, that's it, and we're going to practice it up.